Mr. B. Dhanasega is working as a lecturer in Department of Information Technology, Anna University, Chennai. He finished his MCA from Urumu Dhanalakshmi College, Bharatidasan University. He finished his ME in Computer Science and Engineering from College of Engineering, Anna University. His areas of interest are multi-core programming and architecture, programming models, compiler, automata theory, cryptography, and algorithms. He is an expert in subjects like compiler design, formal languages and automata theory, analysis of algorithms. His research area is code generation for multi-core architecture.
Welcome to the UGC lecture series on computer science, and we have the subject that is compiler design. So, this is the 6th episode of the compiler design subject. So, as far as the previous episode is concerned, we have studied that is how we are designing a lexical analyzer. So, lexical analyzer, that is the very first phase of the compilation, which is operating on character by character of the source program, which will read one character and second character and keep on reading and continuously forming the tokens which are there in the source program, which will be in turn read by the parser, that is the syntax analyzer, which just follows the lexical analyzer phases of your compilation process. And for the recognition of the tokens, so we have seen that is how it is being done with the help of transition diagram kind of things. So, we have seen says program segment which will be reading, that is various token, that is various symbols, and for every symbol being read from the source program, so which will be that is the state will be changed, and whenever we find that the state has been reached, the final state has been reached, we will return some token from the source program. So, that is what being done as far as lexical analyzer is concerned. As far as this episode is concerned, we are having the topic called lexical errors, and followed by how the things are all the tokens are all recognized with the help of regular expressions. So, first of all, that is what is the meaning of an error as far as the compilation process is concerned. So, errors can be detected even in the lexical analysis phase or the syntax analyzer phase, or even it is possible to have errors on the later phase of the compilation also. First, let us see that is what is an error. So, if anything is not satisfying the specification of the language, so whether it is a token structure or the there is the syntax of a statement, whatever it is, if it is not satisfying the specification of the language, then we will be calling it as an error. So, one error in a programming language may not be an error as far as a different language is concerned, maybe because of the specification of the programming language differs for those two languages. So, we must know that is what is going to be the requirement for a language. So, what is the token structure and what is going to be the operators, and then what is going to be the statement structure. So, once we know all these things, we will be able to say whether something is an error or not. And the next is, on seeing an error, what the compiler will do. So, we have already seen one kind of translator called the interpreter. What it does is, on seeing an error, it will stop and it will expect the programmer to correct the error, and later only it will continue with the compilation of this translation of the remaining program. But whereas a compiler is concerned, an efficient compiler is supposed to return as many errors as possible from the which are there in the program, so that the programmer will have some opportunity for correcting almost all the errors available in the source program. The compiler stops the compilation either on completion of the entire compilation process, or it may not be able to continue further. It is because of due to so much of errors available in the error, or will not be able to recover from the errors. So, the compiler has to supposed to find out as many errors as there are available in the source program. But what happens on seeing an error? So, on seeing an error, if the compiler just report and stop there, then it will not be able to continue further with the compilation of the remaining input. So, what we should do here is make the compiler to detect, then report, and then recover, so that the compilation will continue for the remaining program. The compiler is, if it is just detecting, okay, fine, it is telling you that the error is there. So, error is, it will stop the compilation, and reporting, it will report the programmer that this is what the error available in a particular place or in a particular function or in a particular line of statement. But if it can't recover from the error, then it will fail to continue the compilation of the remaining input, whether it is going to be valid or invalid one. So, in that case your compiler stops for every error. So, your programmer will be forced to correct the error as and when the errors are detected by the compiler. But now we are expecting the compiler to detect as many errors as there are in the which are there in the source program. So, we need to have a recovery process by repairing the error. Recovery is not an easy job. So, we must repair the error. So, for example, if I am having a statement like a plus expression like a plus b, so we find there is no error. But suppose if it is going to be a plus followed by a semicolon, where plus will be either an extraneous there is operator or some b or c is missing, the second operand for the plus is missing. So, in that case the compiler has to recover from the error either by truncating the operator plus or by introducing some constant or an identifier next to plus, so that it will recover from the error and continue the compilation process. So, a good compiler is supposed to detect, report, recover by repairing and then continue the compilation process. So, this is to be done for whatever the errors we are facing as far as the compilation step is concerned. It can be either from the lexical side or from the syntax side or from the intermediate code generation side. In the case of lexical errors, first we should know that is what that error is. The lexical errors, it will be detected by the compiler, the lexical analyzer, and when it could not proceed because of none of the patterns of the for the tokens matches any prefix of the remaining input. That is, it will be keep on reading by symbols, that is in a continuous manner, and they all will be mapped with regular expressions. So, we shall see the regular expressions later. So, the expressions or the patterns which are used for recognizing or the specification of the tokens. See, for example, if you are having an identifier, a letter followed by letter or digit any number of times, that is what the pattern of an identifier. So, it will read a letter and it will map it with an identifier, or it could be even be there is a possibility for having a keyword also. See, for example, then THEN, if it is going to be keyword in some language, and if I am making use of this as an identifier, then it will be a wrong, it will be a mistake. But that will be rectified only by the compiler, there is a syntax analyzer, not by the that is your lexical analyzer. But what will happen is this pattern will be mapped with both keyword as well as with the identifier, because the satisfying the pattern for identifier as well as satisfying the pattern for a keyword called then. But whenever we find that the characters we are reading from the source program could not be mapped with any pattern which is already described or already described in the specification of the lexical constructs, then your lexical analyzer will find that or will report some error. So, if the token structure is or the tokens which you are ready that getting from the source program or the lexemes which are getting from the source program could not be matched with the already predefined, that is token structures or token specification, then the lexical analyzer fails to find out a or report a valid token. It will detect some error and report to the programmer. So, that is what the meaning of a lexical error is. Now, so what happens on seeing this lexical error? So, it has to do certain things. So, the simplest strategy is to see whether the prefix of the remaining input can be transformed into a valid lexeme by single transformation. So, the intention is actually we find the lexical analyzer reports error, it is because of it could not find out a valid token. So, now we have to make a valid token from the input. To make a valid token, we have to go for the simplest strategies. You do not make it as a very complicated process, because the intention is we know that there is an error, it has been reported, and then the intention is to recover from the error, not correcting the error. So, with minimal amount of steps of operations or with minimal amount of complexity, we must recover from the error, so that the compiler will continue the compilation of the remaining input. So, what will be the simple strategy? It can be either deleting a character or inserting a character or updating a character or transposition of characters, that is replacing just swapping two characters. These are the possible things a compiler can do, that is a lexical analyzer can do, so that we make it as a valid token and after making it as a valid token, the compiler will report that token to the parser. And one important thing here we have to understand is, the after the transposition or after the deletion or after the insertion or after the updation, there is no guarantee that the token which we are returning to the parser will be the token actually intended by the programmer. So, it can be a valid token as far as that particular context is concerned, but it may not be a valid token as per the programmer specification is concerned or the program specification is concerned. So, that is what we say that the intention is just to recover from the error rather than correcting the error. So, that is what we call it as a simplest strategy. It will be transforming or single transformation such as delete operations or insert operation or replacing or transformation of two symbols. But what will be the next case? That is, the more general strategy is, we will find out the smallest number of transformations needed to convert the source program into the one that consists of only valid lexemes. The most simplest one is going to be a single symbol process. It can be a single insertion or single deletion or single updation. And if you want to make it little, that is efficient one, then we will try to find out the operations, that is minimal amount of operations, not necessarily a single updation, single character of that is operation. It is going to be a minimal amount of operation such that we will be able to make the invalid token into a valid token. So, this will be normally done by the minimum Hamming distance approach. So, for example, if you are finding that there is an identifier like that is max 1 is there, but mistakenly we have made it as 1 followed by max. So, 1 followed by max is cannot be a valid identifier, because identifiers are supposed to start with a letter, not by a digit. So, what can be done is, it can be converted into max 1 rather than 1 max. So, the first symbol available in the identifier, that is a digit, is to be moved on to the last position. So, how this will be done? See, if this identifier is already existing in the symbol table because of a correct valid declaration available in the source program. So, now this 1 max will be matched with the already existing identifiers which are there in the symbol table of the compilation process. So, this 1 max and max 1 will be having a closest match, because they differ by exactly that is a position of a symbol, not more than that. So, we find that a minimum distance match, the match is going to have very smaller amount of corrections or differences, and what will happen is, this 1 max will be replaced by max 1, since there is an entry for symbol, there is max 1 in the symbol table. So, that is what we call it as the minimal, that is amount of corrections required for transforming an invalid token into a valid token. But this is little harder than or little complex when you are comparing with a single character transformation. In the case of single character transformation, most of the time what this compiler will do is, or the lexical analyzer will do is, will remove a character from the input and will continue with the remaining input, provided this will solve the problem. So, the second strategy is, we will go for finding that is the smallest number of corrections or transformations, so that we will be able to get a valid token. But the most familiar one is going to be the panic mode recovery operation. So, it will it is going for deleting successive characters. That is, so far we have seen one character deletion or some transformation that requires minimal amount of corrections, and but now we do not even know how many number of deletions are going to happen. We will keep on truncating tokens. We will keep on truncating the tokens from the that is input, so that we will find out a synchronizing token from the input for the current context. So, that is what we call it as the panic mode of recovery. So, we will continue this lecture after a short break. Welcome back. We are seeing the panic mode of operations. So, as far as the lexical analyzer is concerned, so once it find that there is an error, or once it detects some error, the lexical analyzer has to repair the error so that it can recover from the error and continue the compilation of the remaining process, remaining program. So, for that it will keep truncating the non synchronizing symbols. So, if it is going to be something like an expression a followed by plus 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 etc., followed by a semicolon. So, we know that plus can be a valid token, but it is not going to be plus followed by continuously so many number of pluses, but a followed by a semicolon is going to be a synchronizing token on that context. A followed by a semicolon means that is going to be the end of that particular expression or the statement. So, what this lexical analyzer will do here is, if it is following the panic mode of operation, panic mode of recovery operation, it will keep on truncating the symbols until we find, or the panic mode recovery operation finds a valid token or a synchronizing token with the previous token. So, if it is going to be an assignment statement like a is equal to b followed by a semicolon, it is a valid statement, but if it is a is equal to b plus 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 followed by a semicolon next to b, so there is no point in having this many number of pluses because there is no identifier just following that plus. So, the panic mode of operation will go for removing the pluses from the source program, and it will replace, that is it will remove those plus symbols, and finally semicolon will be obtained. So, that is going to be a valid token which is denoting the termination of a statement, but it is synchronizing with the b. So, your statement will be converted into a valid statement like a is equal to b followed by a semicolon, which is an assignment statement. But most of the time the drawback with this scheme is it may confuse the parser. Sometimes a valid expression will be converted into a single identifier, or another statement, maybe a command statement will be completely truncated, so that the exact context of the program may even change, or exact meaning of the program may even change. It is because of there is a chance that too many number of symbols may be discarded from the source program to find out a synchronizing token. So, that is the issue with your panic mode of operation, but this is the most efficient method, because if you are interested in recovering from the error, no matter whether the program will be transferred into a valid sequence or it will be transformed into a completely unintended, that is sequence, that is not an issue. The intention is just come out of the error and find out the next error if there is an error available in the program. So, that is the reason why most of the compilers they are following the panic mode of that is recovery process. So, we can have an example. So, this is what the example which I have given for you. We have a statement called sum is equal to 2a plus b plus semicolon. So, there are many cases. So, you can't say that exactly one possible transformation will do the that is correction of this error or recovery from this error. You see that what happens here is I am transforming this sum is equal to a plus b by deleting a symbol, not deleting one symbol, deleting two symbols. One is the 2 from the source program, and another one is plus from the source program. So, we will be having sum is equal to a plus b followed by a semicolon, which will be a valid sequence or valid statement, or it can be insertion of symbols. So, we insert two number of symbol there is tokens into the source program. One is actually the 2, one is 2 is one, sorry, plus is the first symbol which we introduced, and another 0 has been introduced here. So, now this expression becomes 2 plus a plus b plus 0. So, followed by a semicolon, it is as a result of the insertion of the symbol, and then next one is we find that a transposition of symbols. So, a2 is the outcome. Actually what we are given as 2a, 2a cannot be a valid identifier. So, we will transform it into a2, and then we are having a binary operator plus followed by an unary operator plus. It is once again there is the b plus has been transformed into plus b. So, this will be considered as a binary operator plus followed by an unary operator plus. So, it will be a valid expression. So, here we have to understand that the intention of the user is just to recover, the compiler is just to recover from the error rather than correcting the errors, and sometimes the parser is playing some amount of role in identifying the appropriate token, because only the parser knows what can be a valid or a synchronizing token. The lexical analyzer knows what is the pattern for a statement only, but whereas a parser it is knowing what is going to be the syntax. For example, if A has been already recognized and plus has also been recognized, only the parser knows that the next token should be either a identifier or going to be a constant. But on that context, if the lexical analyzer returns a semicolon, then the parser will not be able to proceed because it will find another error there. Semicolon is also a valid token, plus is also a valid token, the tokens are okay, but when you combine them or this when you arrange the tokens in the sequence as we are getting from the source program, the parser will fail to find out a valid expression or an assignment statement. So, that is the reason why the parser will play a little amount of role in identifying the correct error from the source program and how it will be recovered from the that is error. So, that is about the lexical analyzer, and now we are having another topic called regular expressions. So, we know that it is going to be simple expressions which will be defining a language called that is regular language or otherwise called regular set. First of all, you should know that is what is the reason for this regular expressions, reason for having these regular expressions. So, we have studied tokens and they are the elements of the lexical analyzers which will be produced by the lexical analyzer. So, now the question is what is going to be the general way of describing those tokens, so that we will be able to construct finite automata and that will keep on finding the tokens from the source program. The tool being used for describing these tokens which are available in the source program is called the regular expression. So, we will make use of this regular expression for identifying tokens or even describing the tokens. For every token, that is whether it is going to be an identifier or a constant or a keyword or it is an operator or termination symbols. So, they all will be described with the help of corresponding regular expressions. So, now what is the way in which regular expressions are generated? See, sometimes the tokens will be very small, like one character, that is one symbol tokens like the terminator or certain operators. So, they all will be available in a single character that is strings. But whereas sometimes it will be even a very lengthier token also, for example keyword or even an identifier or a function name or an there is identifier name like very lengthy that is names. So, in that case the token name is going to be quite lengthier, even we can have a very large number with 10 digits or even more, but your lexical analyzer should be able to recognize those tokens. So, for that reason we go for the description tool, or as we call it as the expressions called regular expressions. So, now the question is how do you write regular expressions for any expression, that is what the meaning. So, we have two cases, one is going to be the basis case, another one is going to be the induction. So, in the basis case we have an empty symbol that is epsilon, which will be a regular expression denoting the language called epsilon, and another one any symbol A, then we will be calling it as the regular expression for describing the language called A. But when you go for constructing complex regular expressions, that is larger regular expressions are built by the help of the induction from the smaller regular expressions by using certain operators. The first one is OR operation. So, you are assuming that there are two regular expressions given for A, one is R, another one is S. So, these regular expressions they will be generating their own languages, the languages are LR and another one is LS. So, now the question is how do you form a new language with the help of an OR operation. The meaning of OR operation is either a string from the language recognized by regular expression R or a string from the language recognized by the regular expression called S. So, we denote the language recognized by this new regular expression as LR union LS, and similarly we will be having the concatenation, it is either a presence of a dot or simply combining R and S. So, the meaning is here you write a string from R and immediately followed by a string from S. So, that is what we write the regular expression or the language as LR dot LS. Then R star is a regular expression. So, that is normally called Kleene closure. So, the meaning of this Kleene closure is 0 or more number of times of the regular expression called R. So, we will write the language of the regular expression as L R star, which is called the Kleene closure. So, any string from R, but that can be repeated 0 or any number of times. And another regular expression is any regular expression within a bracket So, normally this will be used for changing the priorities of the operators. We know that these are the binary operations union, dot, and dot takes more priority than union, and then star takes the closure that is going to have the highest priority. And if you are interested in changing the priority of some operators, then we will go for introducing brackets wherever it is needed, but the language is not going to change just because of introducing a bracket. That is why we find that opening bracket or closing bracket is a regular expression denoting L of R, where L of R stands for the language recognized by the regular expression R. So, now we have another regular expression, that is we call it as R plus. So, there is a regular expression denoting the language containing one or more instances of the strings from L of R. So, R star, I said it is going to be 0 or more number of times of R, and R plus is slightly different. The only one string missing is empty string. So, irrespective of whether it is going to be whatever be the alphabet is, we will not be having empty string as far as R plus is concerned. So, we will go for there is a language where the pattern is expected to occur at least once from the source program. So, then the relationship here it is R plus is R followed by R star, that is at least one time. Then we have another one called R question mark, so which is going to be 1 or 0 number of times of R. So, if you want to have a pattern or not have a pattern, then we can go for question mark, which will give you the regular expression appropriate for that. So, that is about the definition for the regular expression, and to summarize, we have seen the lexical errors, how they are all detected and how it is going to be the recovery strategy for that, and also we have seen the that is definition of regular expression. Here the questions are that is when does a scanner detect an error, that is what is the source of error and how it is being recovered from the lexical error. So, what are the regular expressions, and then we have that is you may be asked to write the regular expression for various patterns available in a source program. So, that is all about the possible questions from this that is particular topic we have seen so far. So, with this I complete this episode. Thank you all.